China aims to restore almost 6,700,000 hectares of desert areas with grassland and forests by 2025. One of the goals of fighting desertification in China is to ensure the country's food security.
There are two main aspects of restoring lands degraded by desertification. Firstly, it requires local sources of native seeds that are suitable and sufficient for ecological restoration in order to meet ecological needs of the specific region.
The battle against desertification also aims to reduce pollution levels in the country. This year, sandstorms have become more widespread, longer, and more frequent in China.
Our goal is not only to restore and protect grasslands for contemplation purposes only, but also to achieve the integration of production, livelihood, and ecology. This is in line with the concept of community of shared future for humanity as proposed by the General Secretary, where animals, plants, and humans share a common home.
The desert doesn't move like a place. It moves like a predator. Across northern China, dunes creep forward in slow, predatory silence, burying roads, swallowing villages, and turning fertile land into a wasteland of drifting gold. For decades, people thought nothing could stop it. Until now, because today, in regions once considered uninhabitable, entire landscapes are transforming before people's eyes. Massive steel machines crawl across the sand like armored creatures, drilling, planting, stabilizing, and sculpting dunes with unnatural precision. Drones descend from the sky like swarms of metallic locusts, spreading seeds and spraying living soil. And from the ground, grids and patterns appear, carved with geometric perfection into dunes that once shifted with every breath of wind. To some viewers online, it looks like a miracle. To others, it looks impossible. But this is not a rumor, not a CGI effect, not a myth. This is the story of the machines that are reshaping China's deserts at a pace few believed possible. A story that spans decades of human struggle, scientific obsession, and a race against a force older than civilization itself. This is how China is turning back the desert. The desert that almost won. To understand why these machines exist, we must go back to a time when China feared the desert more than any enemy. For thousands of years, northern China lived on the razor's edge between survival and collapse. Regions like Inner Mongolia, Ningxia, Gansu, and Xinjiang were shaped by the wind that carried dust, sand, and drought across vast distances. But in the 20th century, something changed. Something broke. Grasslands that once held the soil together began to disappear. Climate cycles shifted. Population soared. Livestock numbers exploded. Forests vanished under axes and plows. And the desert advanced. In some places, it moved so fast that villagers woke to find dunes climbing the walls of their homes. Farmers abandoned orchards swallowed overnight. Children walked to school through storms so thick the sun disappeared. Beijing, hundreds of kilometers away, was sometimes coated in yellow haze that turned daylight into an orange blur. China faced a truth no nation wants to face. Nature was not waiting. Nature was taking back the land. By the 1970s, over a quarter of northern China was degrading into desert. It was a slow, suffocating disaster, one that threatened food supplies, transportation, and entire regions of life. Something had to change. The first great experiment. In 1978, China launched a project so huge that many doubted it was even possible. An enormous ecological barrier stretching across thousands of kilometers, sometimes called the Green Great Wall. Its goal? To hold back the desert by planting millions of trees, shrubs, and windbreaks. The idea was bold, heroic, desperately necessary. But the execution? Brutal. Workers dug with shovels under burning sun, in shifting sand that fought back with every step. Straw fences had to be buried by hand. Saplings had to be carried in baskets. Water had to be dragged across empty plains by donkey or tractor. The desert resisted. If a windstorm came early, months of work could disappear in a single afternoon. Some regions saw survival rates of 20% or less. The project continued, But it was clear. Human muscle alone could not defeat the sand. The real breakthrough would come from a place few expected, a barren desert in Inner Mongolia that would become one of the greatest environmental laboratories in the world. The desert of impossible dreams. The Kubuqi Desert. A name once spoken with dread. A place where roads vanished under dunes and herders lost entire herds to moving sand. A region so deadly that people called it the Sea of Death. But Kubuqi would become the birthplace of the technologies now reshaping deserts across China. The transformation began in the 1980s and 1990s with a strange partnership. Local herder communities, government support, and a private ecological company experimenting with ideas no one had tried at scale. The goal wasn't just to plant trees. It was to understand the desert, its moods, its weaknesses, its hidden logic. And slowly, patterns emerged. They discovered that certain shrubs could survive where nothing else did, that dunes could be immobilized with geometric precision, that microbes could build soil faster than nature. That machinery, not manpower, would be the real answer. Kubuqi became a desert classroom, a testing ground for invention. And the first major breakthrough was something simple, ancient, yet revolutionary when powered by machines. The grid that stops the wind. Long before modern engineering, desert villagers discovered a secret. If you plant straw in the shape of a checkerboard, you break the wind's power. Each 1 by 1 meter square reduces the wind's speed, trapping sand and creating a surface that resists movement. It works. Always has. But there was a problem. It took forever. Manually laying straw grids across thousands of hectares was backbreaking and slow. One storm could erase weeks of work. So engineers introduced something new: the automatic checkerboard laying machine. A machine the size of a small tractor that crawls across dunes, unrolling biodegradable mesh or straw grids, pinning them down with steel spikes, and filling each square with material that holds the sand in place. Where humans could cover a few hundred square meters a day, these machines could cover acres. A dune that once shifted every week could be immobilized in a matter of hours. For the first time, the desert lost its ability to move. The machines could now enter safely. The machine that plants a forest in hours. Once the sand is stabilized, the next phase begins: planting. For decades, people planted saplings by hand, one tree at a time, one hole at a time. It was noble work, but painfully slow. Then came a machine that changed everything. In China, it's known simply as the intelligent tree planting machine. There isn't one model. There isn't one company. It is a class of machines built across desert provinces, each one designed to perform nature's slow labor at industrial speed. Then it moves forward, again and again without stopping. Some machines plant hundreds of saplings per hour. A fleet of them can transform a barren landscape in a single day. This is the footage that often goes viral. Rows of perfect little basins appearing in the sand like dimples on a vast golden skin. But planting is only part of the strategy. To reshape a desert, China learned it had to use both earth and sky. The drones that turn air into an ecosystem. Watching China's desert drones is like watching a science fiction movie. They rise in synchronized fleets, machines of all sizes, from backpack-sized quadcopters to large agricultural drones capable of carrying heavy payloads. Their missions are precise: seeding steep dune slopes, hydrating remote seedlings, analyzing soil conditions, monitoring survival rates, spraying nutrients and microbes, mapping terrain for machine routes. In the past, workers had to climb dangerous dunes by hand. Now drones do the work in minutes. Some drone teams drop seed bombs, pellets coated in clay and nutrients that protect seeds until rain arrives. Others mist dunes with a special solution that nourishes the next stage of restoration. Together with ground machines, these drones create a two-layer approach, a rebuilding of the desert from both above and below. But the most surprising part of the system isn't mechanical at all. It's biological, a living technology that changes the desert from the inside out, the living crust that waits inside the sand. In laboratories across Inner Mongolia and Gansu, scientists studied one of Earth's oldest life forms, cyanobacteria. These microscopic organisms, billions of years old, have a superpower. They can bind sand. If sprayed on dunes under the right conditions, they grow into a thin, dark crust that holds sand in place, traps moisture, adds organic material, creates a foundation for grasses. This crust becomes the skin of a new landscape. Machines spray it, nature strengthens it. And what was once shifting sand becomes a stable habitat. To many, it feels like magic, turning desert into something that supports life. But the reality is beautiful in its simplicity. Help nature do what nature does best, only faster. The deeply human battle against the desert. Behind every machine is a person whose life once depended on the desert not winning. A farmer in Inner Mongolia who once slept listening to dunes scrape against his door. A herder who watched grasslands vanish, forcing him to sell half his livestock. A schoolchild who walked to class through storms so thick he couldn't see his own hands. These machines aren't about shiny technology. They're about survival. In one Kubuqi village, elders recall a time when children had to tie ropes between houses because sandstorms blinded everyone during the walk to school. Today, that same village has trees tall enough to cast shade in summer. Families grow medicinal herbs on land that was once bare sand. Young people who once fled to cities now return to work in desert restoration teams. The machines did not just reshape landscapes, they reshaped futures. When the desert starts to heal itself, the most incredible transformation does not happen when machines are running. It happens after they leave. Once the dunes are stabilized, once pioneer shrubs take root, once the sand crust forms, a quiet shift begins. Wind slows, soil thickens, insects appear, birds follow them. Plants seed themselves without human hands. Roots spread across slopes. Small animals return to graze. An ecosystem awakens. This is the desert's secret. Given a foothold, it will rebuild itself. Machines create order. Nature creates life. This process, called ecological succession, is the slow heartbeat of the desert healing. And it is the real reason China's system works. The industry built out of sand. Desert restoration is no longer a side project. It is an industry. In Inner Mongolia, companies now specialize in desert planters, stabilization grids, seed drone fleets, soil crust sprayers, irrigation robots, drought-hardy shrubs, ecological monitoring systems. The Psychic Sing Sand Industry Group builds machines specifically designed to survive sandstorms, blazing sun, and uneven terrain. Local universities operate research stations deep inside deserts, studying dune movement, plant genetics, and wind patterns. For the first time in China's history, deserts are not only being stopped, they are being understood. How this became the world's largest desert laboratory. Across the world, nations struggle with desertification. India, Pakistan, Egypt, Saudi Arabia, Morocco, Kazakhstan, Mongolia, even the American Southwest. But China has something unique: landscape, population, funding, and national urgency. Over decades, that urgency built the largest desert research network in the world, the largest afforestation program in history, the largest drone reforestation fleets, an entire ecosystem of desert machinery, thousands of trained engineers and technicians, fully transformed regions like Kubuqi, Mu Us, and parts of Tengger. Today, Chinese deserts serve as a global classroom. Scientists, engineers, and politicians from dozens of countries now visit Kubuqi to study how China achieved something many thought impossible. And this story is far from finished. The highway that should not exist. If you want to see how far this technology has come, you must travel to a place once considered impossible to cross. The Taklamakan Desert. A name that means, if you go in, you won't come out. For centuries, traders on the Silk Road skirted its edges, terrified of its shifting dunes. Travelers who wandered too far never returned. Even modern engineers believed it could never be tamed. Then, China built a highway straight through its heart. But a road inside one of the world's most dangerous shifting sand deserts faces a unique threat. The desert tries to bury it every single day. So, how did they stop a road from being swallowed? With a fully mechanized defense line, a ribbon of life in a sea of sand. Along both sides of the Taklamakan Highway stretches a continuous green belt. Miles of shrubs, grasses, and hardy species planted with the same machines described earlier. Automatic grid installers, intelligent tree planting machines, sand compaction vehicles, drip irrigation systems, patrol robots, and drone monitoring teams. Every few meters, pipes buried beneath the dunes drip water directly to the roots of drought-resistant shrubs. Workers who once fought dunes with shovels now operate fleets of machines that maintain the highway's ecosystem like clockwork. And this ecosystem works. Where once dunes buried even heavy equipment, now shrubs grip the sand like anchors. The highway remains open, defying the desert every day since the machines arrived. It is proof of something extraordinary. With the right technology, even the deadliest deserts can be reshaped. The Mu Us miracle. A desert that disappeared. The Mu Us Desert, once a symbol of ecological collapse, is now one of China's greatest environmental turnarounds. Decades ago, Mu Us was a wasteland of rolling dunes. Villages were abandoned. Crops failed year after year. People called it a slow-motion disaster zone. Today, large swaths of Mu Us are green. Shrubs stretch across old dune lines. Grasslands shimmer where sandstorms once roared. Water returns to seasonal rivers that had dried for decades. Birds and foxes roam areas where nothing lived before. How did this happen? Through a relentless combination of mechanical sand stabilization, drone-led seeding, water-guiding trenches dug by autonomous machines, millions of hardy shrubs planted by intelligent planters, and careful ecological management from local communities. Locals say the transformation was so fast that some didn't believe it until they saw it. Where we once saw only yellow, one herder said, we now see green. The Mu Us Desert became a symbol of hope, not just for China, but for the world, because it proved that even the most degraded lands can return once machines give nature a chance to breathe again. Machines that don't sleep. In recent years, China has begun building something even more ambitious: autonomous desert robots. These are not prototypes. They already work in several regions. These machines include self-driving sand stabilization vehicles, autonomous grid installation robots, watering rovers guided by satellite, ground drones that track plant growth, and small, beetle-sized bots that sense moisture and soil health. Some operate at night, guided only by LiDAR and moonlight. Imagine a vast desert, silent and empty, except for the hum of machines moving alone across the darkness. Drilling holes, planting shrubs, compacting sand, spraying microbial crust, and mapping every dune. No human footsteps, no headlights, just technology quietly rewriting the land. These robots are not replacing people. They are giving them back their land. A new economy grows from the sand. Something unexpected happened in places like Kubuqi and Mu Us. Once the land stabilized, a new economy appeared. Local farmers began planting licorice goji berries, edible herbs, desert-compatible fruits, medicinal plants used in traditional Chinese medicine. Companies built solar farms on stabilized land. Tourism grew around desert forests and restored lakes. Communities opened eco-lodges. Children who once fled the region now returned to work in restoration teams. The desert stopped being an enemy. It became an opportunity. It is one of the greatest socioeconomic transformations in China's modern history, and few outside the country know it ever happened. The critics and the hard questions. Even with its success, China's desert transformation raises difficult questions. Water use. Some methods require irrigation, and water is limited in arid regions. Monoculture forests. Early projects planted too many water-thirsty species like poplars. Maintenance. New vegetation must survive long-term climate shifts. Community impact. Some critics argue restoration should rely more on traditional herders. Ecological balance. Too much planting can create artificial ecosystems that need constant human support. But China has learned from these mistakes. Recent years focus less on forest belts and more on mixed shrubs, native species, grassland recovery, biological soil crust, natural regeneration, water-smart planting systems. The goal has shifted from plant trees to restore ecosystems. Restoration is no longer about forcing green where nature doesn't want it. It's about rebuilding the desert's natural resilience. The truth behind reshaping deserts overnight. Let's answer the question directly. Can China reshape deserts overnight? Here is the real truth. Machines reshape the surface overnight. Nature reshapes the soul over years. The checkerboards appear instantly. The saplings appear instantly. The drone patterns appear instantly. The biological crust darkens the sand instantly. Those visuals online, the ones that feel impossible, are real. But the transformation behind those visuals is deeper than a time lapse. It is the desert learning to breathe again. The philosophical heart of the story. There is something poetic about the idea of reshaping a desert. For centuries, humans saw deserts as endings. Endings of rivers, endings of forests, endings of civilizations. But this story suggests something different. Deserts are not dead. They are waiting for stability, waiting for moisture, waiting for life to gain a foothold. The machines do not conquer the desert. They reveal its potential, a potential millions believed was impossible. So what do we make of all this? What does it mean that a nation can now reshape dunes with machines, drones, microbes, and patient, quiet labor? It means that climate disasters are not final, that deserts are not destiny, that land once lost can be returned, and that humanity's relationship with nature is not a battle, but a negotiation where innovation acts as the translator. The desert will always be ancient. It will always be powerful. It will always be wild. But for the first time in human history, we are learning to reshape it. Not by force, not by fantasy, but by understanding the secret language of sand. Do you think humans should reshape deserts? Or should deserts remain untouched? Tell me in the comments. And if you want a deep dive into one specific machine from this story, let me know. There is much more to reveal.